So this problem is going to ask us to write a linear function that will model the cost of manufacturing bicycles. And I added an explanatory note at the beginning to give you an idea of what a linear model is. So this is a common linear model that we call the cost function. And the simplest form of a cost function is the linear function c of x equals m, which we would call a slope, but here is our rate of change, times x plus b, which would be that point where x is 0. So the y-intercept b represents the fixed cost of operating the business. So those are things you have to pay whether you're making any money or not. And the slope is what represents the variable cost. So how much materials it takes per unit manufactured, how many man hours it costs in order to manufacture the bicycles. So those will change. So here's our context. Suppose a small bicycle manufacturer has fixed daily cost of $2,000. And each bicycle costs $90 to manufacture. Write a linear function that expresses the cost of manufacturing X bicycles in a day. So let's go back to the general form of c of x equals mx plus b, where the y-intercept is our fixed cost. So here's our fixed cost. So that means b equals 2,000, and I'm analyzing what was given in my problem. And then each bicycle will cost $90 to manufacture. And here we have that the slope represents the variable cost, or what changes. At what it costs to buy materials today, it will cost the company $90 to manufacture a bicycle. But as the rates of materials and the rates of wages go up, then that could change that $90 per bicycle. So now we write our function as c of x equals our variable cost, or those associated with the slope, or the m, and that is $90, and that's times x. And then we add to that the fixed cost, the $2,000 that is always there, that must always be paid. And what we've constructed here is a linear model that represents the cost to manufacture bicycles at this particular company.